The objectives for this lesson are to distinguish the difference between explicit form and implicit form, and also to find the derivative of a function using this form. Explicit form is when functions are expressed as a function of x. With functions like these, it is easy to find dy over dx, the derivative. Implicit form is when the x and y of an equation are intermixed, making it difficult to find dy over dx.
So an example of an equation that's written explicitly would be y equals 1 over x, and this written in implicit form would be xy equals 1. See how the x and the y are intermixed? So now let's try to derive this equation implicitly. So we're just going to use product rule and derive in terms of x like any other equation. So first you would do the derivative of x, which is 1 times just y because you don't derive that, and then plus x times the derivative of y, which is 1. But after every time you derive the term of y, since you're doing it in terms of x, you would have to put dy over dx. And then the derivative of 1 is just 0. So this derived implicitly would just be y plus x dy over dx equals 0. Now to get the dy over dx onto one side, you just subtract the y, so it would be x dy over dx equals to negative y. And now you're trying to isolate this by itself without any terms in front of it, so you just derive by x on both sides. So your final derivative that you have derived implicitly is dy over dx equals negative y over x. Okay, so now we're going to do a second example problem, which is, let's try x plus 3y equals 11y squared. So first, like I said, you just derive in terms of x. So that would be 1 plus 3 dy over dx, gotta remember the dy over dx, equals 22y dy over dx. Since there are two terms that involve a dy over dx as a factor, you can bring them onto one side and bring this other term onto the right side. So it would be 3 dy dx minus 22y dy over dx equals to negative 1. And since these have a common factor, you can factor out the dy over dx, which gives you dy over dx times 3 minus 22y equals negative 1. Now all you need to do is isolate the dy over dx, so you just derive by 3 minus 22y on both sides. So at the end, your derivative would be negative 1 over 3 minus 22y. So for our third example, we're going to find the equation of the tangent line at point root 2 comma negative root 2 over 2 on the graph of x squared plus 4y squared equals 4. So first you'd have to know the equation for tangent line approximation, which is y minus f of x is equal to the derivative of f of x times x minus c. This is basically kind of point slope form. So then now we'd have to find the derivative of f of x at this given point. So in order to do this, you'd have to derive this equation implicitly. So we just do it like we've always been doing. 2x plus 8y dy over dx equals 0. And you bring this to one side, so 8y dy over dx is equal to negative 2x, derived by 8y on both sides, which gives you dy over dx equals negative 2x over 8y, which is the same thing as negative x over 4y, and this is the equation for your derivative. So what you do now is you plug in the x and y values at the given point. So dy over dx, so the derivative at point root 2 comma negative root 2 over 2 would be, so negative x is negative root 2 4 times negative root 2 over 2. Simplify this, negative root 2 over negative 4 root 2 over 2, which is equal to 2 root 2 over negative 4 root 2. These two cancel out, just gives you negative 1/2. Oh, sorry, wait. This one's negative, and this one's negative, which gives you a positive, so positive 1/2 is your slope at this point, which is the derivative of f of x. So then you just plug in what you're given into the equation. So y minus f of x, which is given here, negative root 2 over 2, but since it's minus negative, it becomes a plus. Y plus root 2 over 2 is equal to the derivative of f of x, which is 1/2, times x minus c, which is x minus root 2. This is the equation of the tangent line. And you can tell this by checking it on the graph, which looks somewhat like this. So it would be right here. Yeah. For our last example, we're going to find the second derivative at point negative 3, 4 with the given equation x squared plus y squared equals 25. So first we have to find the first derivative, and in order to do that, you just implicitly derive, like we have been doing, 2x plus 2y dy dx equal to 0. Bring this onto one side. 2y dy over dx is negative 2x. Divide by 2y on both sides, which gives you negative 2x over 2y, which is the same thing as negative x over y. So this is your first derivative equation. And in order to find the second derivative, you just derive this implicitly as well. So the second derivative would be y times negative 1 minus dy over dx is negative x over y squared, because we're just using quotient rule. And you simplify this to give you negative y plus x dy over dx over y squared. Now for dy dx, you plug in what you got for the last first derivative, which is negative x over y. So that gives you negative y plus x negative x over y squared. Simplify this, negative y plus negative x squared over y squared is equal to negative y squared over y minus x squared over y squared. Simplify this even further, and you get negative y squared minus x squared over y cubed. Now here they're asking for the second derivative at this given point, so you just plug in the x and the y. So negative y squared is negative 16 minus x squared, which is 9 over 4 cubed, 64. Simplify this, it's just negative 25 over 64. And that's your second derivative.
Recap what we learned today. Here is how to derive using implicit differentiation. Step 1. Differentiate both sides with respect to x. Step 2. Collect all terms involving dy dx on one side and move other terms to the other side. Step 3. Factor dy dx out of the side of the equation that you have chosen. Step 4. Solve for dy dx.
So here's a real-life example. Say there are two planes. One plane is going at 300 miles per hour and the other one is going about 600 miles per hour. And if you want to find how fast the direct distance is between them is changing, then you would use implicit differentiation.
A real-life example problem is air is being pumped into a spherical balloon at a rate of 3 centimeters cubed per minute. Determine the rate at which the radius of the balloon is increasing when the diameter of the balloon is 10 centimeters. First, you have to look at what's given to you and what you already know. So we know that the volume of a sphere is 4/3 pi r cubed. And what's given is the rate at which the volume is changing, which is 3 centimeters cubed per minute. They also give you the diameter, which is 10, so you know the radius because you divided by 2, so you know the radius is 5. So now you just derive the volume equation, so then it gives you dv over dt equals 4 pi r squared dr over dt. And dr over dt is what you're trying to find because it's the rate at which the radius of the balloon is increasing. So you just plug in what you know, so 3 equals 4 pi times 25 dr over dt, which is 3 equals 100 pi dr over dt, and at the end, when you simplify everything and bring dr over dt onto one side, it's 3 over 100 pi.